Gliese 229b, 160 megameters. Gliese 229b is a brown dwarf. It orbits a larger dwarf star, Gliese 229a. Gliese 229b would be classified as a planet, but it's much denser than Jupiter because it's mass too large for consistency. There is a threshold for brown dwarf's mass. That is between 30, 13, and 80 Jupiter masses. Wolf 359. 200 megameters. A small red dwarf dwarfed by normal stars. It is the sixth closest star to Earth after the Sun, Proxima Centauri, Virgo Centaurus, Ptolemy, and Barnard star. Still, its magnitude is a dim 13.5. Trey 4, 260 megameters. It's one of the largest planets discovered. No telescope can actually see Trey 4b, but there's ways to prove its existence indirectly. Trey 4b's gravity causes the star it orbits to wobble slightly. Also, when Trey 4b goes in front of the star, the shine of the star dims a little. This method involving gravity is called radial velocity, while the method involving the dimming of the star due to a planet passing by is called transiting. Not to be confused with occult. That is a different definition. Proxima Centauri, 210 megameters. It's known as being the closest star to Earth other than the Sun. Its name comes from the word proximity. Proxima Centauri is a small red dwarf star. Unfortunately, it is so dim you need a telescope to see it. Distance from Earth to Moon, 380 megameters. The year of the Moon here are not to scale. If the distance were a meter, Earth would be the size of a quarter and the Moon would be the size of a pea. Do you want to know what the crazy fact about this is? Yes, you saw that right. You can fit every other planet between Earth and Moon. Though, and guess what? It's still not enough. Kapteyn Star, 400 megameters. Kapteyn Star is only 13 light years away. Even so, its magnitude is +9. So you need a binoculars to see it. Around 10,000 years ago, Kapteyn Star was only 7 light years away. The culprit? Universe expansion. Luyten Star, 450 megameters. Luyten Star is a red dwarf star 12 light years away from us. It is so close to the star Procyon that Procyon appears 10 times brighter to Luyten Star than Sirius appears to us. Alpha Centauri b, Ptolemy, 1,200 megameters. Alpha Centauri b, or Ptolemy, is the second largest star in the Alpha Centauri system. Its diameter is approximately 1.25 million kilometers, so it's slightly smaller than the Sun. Alpha Centauri A and B, Virgo, Taurus, and Ptolemy, are so close they appear as a single star to us, Tellurians. And here's the Sun. Yes, you saw that correctly. The Sun is not yellow. It's actually white. Anyways, it's 1,400 megameters. Also known as Sol or Helios. The Sun is what gives Earth the energy that makes it able to have life. The Sun is over 100 times larger in diameter than Earth. 20,000 times more solar energy hits the Earth than the human race uses, meaning we are using quite little, which is actually quite good. Speaking of Gliese 229a, here's Gliese 229a, 960 megameters. It is a red dwarf star, a bit smaller than the Sun, but much less massive. The red dwarf star is also known as GJ 229 or GI 229. Actually, that's a lie. That's an GL 229. It is part of a binary star system, the second star being Gliese 229b, which, as we discussed earlier, is a brown dwarf star. By the way, that is Neptune. Minecraft world, and Uranus, all in this three-space water molecule. And speaking of Regicatoris, here's Regicatoris, Alpha Centauri A, 1,700 megameters. Alpha Centauri A is the largest star of the Alpha Centauri system. It boasts of 3 stars, which is the closest star system to us. It is also the 4th brightest star in the night sky. And, worst part, Alpha Centauri is. And from now on, we will use gigameters. A gigameter is 1,000 megameters, a million kilometers. Diane. Speaking of Procyon from Blue Chain Star, Procyon, 2.8 gigameters. Did you know that over the next 10 million years, Procyon will grow to 100 times its current diameter and become red? This is because Procyon's hydrogen is now all helium. The sun will do the same thing in a couple billion years. 5 billion years exact. Well, not exactly. You're wrong, right? Sirius A, 2.3 gigameters. Sirius is the brightest star in the night sky. It is almost twice as bright as Canopus, the second brightest star. However, Sirius is not a large star. It only appears bright because it's close to us, only 8.6 light years away. Pollux, 2.7 gigameters. In Greek mythology, Pollux's twin is Castor. They are also stars in the constellation Gemini, meaning twins. However, in reality, Pollux is a single star, while Castor is 3 binary stars for a total of 6 stars. Castor is a set of 6 tuplets. Altair, 2.8 gigameters. One of the 3 stars in the Summer Triangle. The Summer Triangle is an acute triangle, which means all angles are less than 90 degrees. The other 2 are Vega and Deneb. Like many other stars, Altair spins very quickly, bulging at the center. Vega, 3.5 meters. Found the Lyra constellation, also part of the Summer Triangle, composed of Vega itself, Altair, and Deneb. Vega spins so quickly that it bulges. However, if you see Polon, it looks. We see, however, spins so quickly it bulges. However, we see it pull on, so it looks circular. One major effect of centrifugal force fooling us. Regulus, 6.1 gigameters. Regulus spins so quickly it bulges, just like Altair and Vega. If Regulus were to spin 16% faster, it would rip apart. Regulus is also the brightest star in the constellation Leo. There's also Regulus B and C. Total human height, 10 gigameters. If all the 7.8 billion humans stood on top of one another, and the bottom 7.7 billion humans didn't crumple under all the weight, the stack would be approximately 13 million kilometers tall. Spica, 10 gigameters. Spica is the 15th brightest star in the night sky, and it lies in the constellation Virgo. It's actually a binary star system. The 2 stars are very close, and they orbit every 4 days. Capella, 17 gigameters. Capella is actually a quaternary star system. 4 stars orbit in the system. 2 are G-type giant stars, while the other 2 are M red dwarfs. The largest one is the one you see to the left. The sun is also type G star, but it's the main one. If you want to know what its designation is, it's Capella AA. Arcturus, 36 gigameters. Arcturus is the 3rd brightest star in the night sky, after Ceres and Canopus. It's the brightest star in the constellation Boötes. Find it by following the handle of the Big Dipper. Polaris, 52 gigameters. It's also known as the North Star. It's very near the North Pole, so if you want to know which way is north, just try to find Polaris. Locate the two stars on the far side of the Big Dipper and go upward. It's actually on the very tip of the Little Dipper's handle. On attack, 28 gigameters. On attack illuminates the Flame Nebula. It's also the easternmost star of the three stars that form the Orion's belt. The other two are Alnilam and Mintaka, and all three appear very bright for planet Earth. Oh, and by comparison, on attack is actually very faint, actually. Alberio, 86 gigameters. Alberio is made up of three stars total. Here we are just showing the largest one, Alberio AA. Two of the stars are close and form a yellow dot. The third is blue and further away. The blue star and yellow stars are so far apart, it takes them 100,000 years to complete one orbit. Aldebaran, 63 gigameters. Aldebaran is not to be confused with Alderaan, which is a planet in Star Wars. Alderaan is very similar in Earth in size, day length, and water cover. However, Aldebaran is 4,900 times larger, rotates every 520 Earth days, and has no water. It's literally a star made of plasma. Well, 12. Well, the rest